Hello everyone, welcome to my channel Cryptoware. Welcome to day one of alternate day reverse engineering challenge. And here, each alternate days, we are going to solve an RE challenge, and the challenges will be from crackmes.one, and I'll be solving from very easy level to slightly tricky versions of the challenges. I'm not going to get into the difficult version yet, but we will definitely dive into that also, and we'll see that how easily you can actually identify. So I'll be sharing all the details in the description, like which challenge I'm working on, and you can definitely try that out by yourself. And so today for day one, I'm going to solve this license checker. I'll share the link and everything in the details, in the description. Sorry. So let's get started. So the first step towards understanding or solving an RE challenge is identifying what it does. So here you can see that it is looking for a language. So I'll just choose English, and it is asking for the license key. So I'll just put random, and it says invalid license key. So if you put the correct license, maybe it will show valid license keys or something of that sort. So next thing is we need to check whether this is which like whether it is 32 bit or 62 bit 64 bit. Sorry. So we'll use P Studio. So while downloading also, you can actually see from there, you can get an idea from there as well. Since I have downloaded it long back, so I don't remember. So it's 64 bit. Now, some of the challenges are very easy, like they will not take a lot of time, but the way you have to solve is could be different. For example, we are going to check something else. We are not going to typically use x64 or x32 debugger, or maybe this time we are going to use some other tool, or we are going to solve it using a different way. So that is how all the challenges are there, and that's how we are going to solve them. So they are not similar to each other. They could be similar to one another. All the challenges are there where you have to look for licenses and passwords only. But the way you are solving and what you are looking for is what makes them different, and that is where you are actually going to learn this. So for this challenge, we are going to open Ghidra. Now, it's totally up to you. You can actually open X34, X64. It totally depends upon you. So, I'm talking about my approach. So, for solving these kinds of challenges, I often, first of all, try to see that if I can get any information from the disassembler. That would be my goal, and this is my approach for doing malware analysis also. Instead of directly running it in X32 debugger, we can start with IDA or Ghidra, or try to understand what are the things that we need to identify or analyze. So I'll create new project. So I'll go to desktop, D1. Okay, we can keep it here only. Okay, D1. And we will sometimes you will realize that it's not at all required to use X32 also. Like for example, while you're performing analysis of a malware, the static analysis itself gives you all the information and you understand the code flow. You may not need to run the malware. Sometimes you do run the malware just to understand, like confirm that yes, that's what we understood from the code or not, or if there is something more to it. So here is this. So you can either import it from here, or you can click on I and it will directly import the file. You can use IDA also. It totally depends upon your um, like which tool you are more comfortable with. Personally, I use tool based on what I want to do. Like I would use Ghidra to go through the code. If I can actually see the code, I'll see the disassembler. If I really want to debug it, I'll prefer using X32 or IDA. I am more comfortable with X32, but I have used IDA also. And I have shared some videos also how I have solved using IDA. So it totally depends upon you. Here you have to just understand the approach, and you can follow the same approach while solving the challenges by yourself. So let's wait for a while till it's done. And yes, we'll click on yes. We don't have to check any options for now. So it looks like the analysis is uh, going on. It will be done soon. So it's just few seconds more. I guess it will not take a lot of time. Meanwhile, you can see how it is getting, like we are able to see the code now, and this is where we are going to understand now. Meanwhile, it is getting completely disassembled. Let us understand what we are going to look for. So right now, since these are reverse engineering challenges, so I feel that going through the code initially at the initial stage is much better than directly jumping into the into X32. Sometimes you can actually do that. Sometimes my approach has been directly jumping into dynamic analysis and then identifying that yes, I need to see the code also, because maybe I'm missing out on something over there that will be helpful. So each of these approaches actually together make how you are solving a challenge. The similar approach you can follow towards solving a malware or analyzing a malicious sample as well. So here for this we observed, like if you execute this, you'll see that it asks for language. So this is one thing that we are going to look for. And second, it has given the format of the CTF and it is asking for some digits. We don't know what is the length of the digit. I mean length of the entire license key. So I'm assuming it has to be of this sort. um, so enter license key. So there are two things that we need to look for, and the important thing for us to look for is the enter license key. So, and we'll see that at what condition it tells us that the license key is invalid, and under what condition it says that the license key is valid. We need to get the valid license key. So let's check the whether it is done or not. It's not. So few of the things that we can meanwhile check is, I'll be looking for the main function. It's in progress. This is the main function. So we will start with the main function to understand what is happening, and there are lots of function calls. So we also need to identify which function calls matter the most. Sometimes, like for example, for a malware program which is going to be really huge in size, we may have to go through a lot of functions. Sometimes it happens that initially you may not be able to identify which function is the one we need to analyze, but that's totally okay. This is the part of the process of your learning, so it's important. Here you can see that as it is getting disassembled, we can see argument v, argument c, and you can see a lot of things which are visible now, and we can understand certain things. Well, I was wrong. It did take a while, and it's still taking a while to get completely disassembled, which is totally fine, because after getting disassembled, we can actually see a lot of things which are readable to us. For example, this validate license key, which we are more interested in. So we are able to see this right now, and let's wait for a few more seconds so that we can understand how is the validation happening over here. Well, it's finally done. Is It really did take a while, which is totally fine. Sometimes it takes some time and sometimes it doesn't. So here is validate license key. We are trying to understand how is the condition of the license key is being checked. We are not dealing with the language part because I think that is not as important as this is, because we need to identify what the license key is. So we'll double click on it, and here it is. You can see that param underscore one is what our input is, its pointer here over here. And you can see some of the variables are defined. So initially, if you see that param one, as I mentioned, that it is the input which we are putting as the license key, is length is being checked against scene hex, which is 12. So the length of the license key should be uh, of length 12. Now, here in these few lines, here you can see the string must start with CTF hyphen. So we were not wrong when we mentioned CTF hyphen, and also if you execute the program again, for example, if I run it again and if I mention English, you will see that it has mentioned the key format. So here also it has already been mentioned that the key should start with CTF hyphen. So here you will see that yes, it is checking the prefix, which is CTF hyphen. Then, so here you can see that this part of the code is actually looking for the rest of the part of the license key of which is after CTF hyphen should be an integer. Now here you can see a local 24 is defined, which is dealing with local 68, which is also given over here, which again deals with, or it holds the part which is after CTF hyphen into an integer, and it stores it in local 24 over here. And now this local 24, that is the last, so if it is a length of 12, the length is of 12. So the first four is CTF hyphen to so 12 hyphen 4 will be 8. So the rest of the 8 characters, or the input, that is the next part of the license key, it is calculated over here. So the calculation is done based on these three uh, conditions. So the first condition is the local 24 int, the number mod, this is 3b hex, which is 59, should be C12, as you can see. Again, the number should also be mod 71, which is 113, should be equal to 12. And this, the last byte of the number, and this 255, the number should end with the binary 055. So these are the three conditions. This means, let me be clear again. So the last byte of the number should be should end in binary, which is 055. And if all the three conditions, these three conditions are met, then only we have a valid license key. So here we can see that the license key is getting checked based on three conditions. So there are no hard coded license keys over here. I hope I am able to explain it to you. Let me re-mention each of the steps, or the each of the parts which are important. First of all, it checks for the length of the license key, which is of 12. Now the first four characters of the license key should be CTF hyphen, which is predefined over here. Now the rest of the part should be an integer, which is mentioned. And for the rest of the part, again, there are three conditions which are mentioned over here. Now, these three conditions, only if these three conditions are met, then only we will have a valid license key. So at this point, it is not possible for us to, put something random and then keep on checking. Otherwise, we will keep going through this loop. We need to generate a valid license key right now because we know what the conditions are, and that is why we need to have we can write a code, basically a kind of dictionary attack. Although we are not performing a dictionary attack, we are trying to generate the code based on the conditions given. And I already have a code mentioned over here. Sorry. Let me open it with Notepad. And here you can see that the validation is happening based on these three conditions. Okay, so let's start with the main function. So I've written a Python code. So the keys, it is looking for the keys. It will look for all possible conditions. Total valid. Okay. So find valid keys over here. It has taken an array for number in range. It has defined 8-digit numbers as I mentioned. CTF hyphen, we are not dealing with that. Validate license key is mentioned for format, append key. Okay. Now conditions are here that the number mod 59 should be 12. Number mod 113 should be 12, and the final thing is this one, which is the last byte of the number should be equal to 0, sorry, 0x55. That is, the number ends in binary with 0x55, that is hex. But in here, this may look slightly confusing. I'll try to simplify it a bit. So, this is basically talking about bitwise AND operation that extracts the last byte or the least significant 8 bits of the number local underscore 24. And that is what the condition is over here. So, 0, uh, so this 55, hex 55 means 0, 1, 0 1 0 1 0 1. Okay, in binary. So the check is, do the last 8 bits of the number equal to this. This is actually the check over here. And sorry, this is just the condition. So this is based on how the challenge has been written. So this is just one of the condition, which looks slightly complicated, but that is totally fine. So I hope I'm clear. So this is what it is trying to achieve here. And we simply execute this program. So we'll open it in CMD. You need to have Python installed if you want to run using Python. Otherwise, you can directly, write your own script also. I'll try to share the script, a link of the script over here. And let's see. It may take a while. So after running, it finally gave us this output, and there are 59 valid keys found. So we can try checking these keys against here. Okay, sorry. Yes, so this is the secret key. We have gotten the program activated. If you want to check, um, if you want to see the other any random key, if they are also working or not, so you can just copy paste. So that also gives the valid. So I'll share the script also if you want, but I would really suggest that if you can see the logic, check the logic on your own and try to understand. I know the condition, especially the last one, sounds slightly confusing, but I've tried to explain. Um, Let me know in the comments if you're able to solve this challenge or if you're able to follow me while solving this challenge. And we'll meet in the next alternate day RE challenge of a day 2. So see you then. Please like, share, and subscribe to my channel. And see you.